Hello students, we often use vectors in physics, so today let us study the basics of vector algebra. So what are vectors? A quantity that has magnitude as well as direction is called a vector. That means a vector is simply a line segment which is directed. You generally denote it by an arrow. The point A from which the vector starts is called the initial point and B where it ends is called the terminal point. So if I write vector AB, it is understood that A is the initial point and B is the terminal point and the vector goes from A to B. The magnitude is the distance between the initial and terminal points and it is generally denoted in the mod sign. For example, suppose we want to represent a displacement of 40 kilometers, which is 30 degree west of south. So as shown in the figure, you have the south direction and then you take the west of south direction, which makes an angle of 30 degrees and the magnitude is 40 kilometers. So suppose if we classify the quantities like time, distance, speed, volume, density, work done, etc., they do not have direction. So they are scalar quantities. But the quantities like velocity or force, they have direction. So they are called vector quantities. So while representing a vector, suppose you want in 3 dimension, you have 3 axes x, y and z, 3 axes are there. You represent vector A as x into I cap plus y into j cap plus z into k cap, where I cap, j cap and k cap, they are actually showing the direction in x, y and z axis, along x, y and z axis. The magnitude of the vector x is the magnitude of the vector along x-axis, y along y-axis and z along z-axis. The point, we already know the point where the vector starts is called the tail and the end point of the vector is called the head of the vector. The formula for calculating the magnitude of a vector, suppose you have a vector A which is equal to A I cap plus B j cap plus C k cap, then the magnitude is given by mod of root of a square plus b square plus c square, and you can see that magnitude will be a scalar quantity. Note that the above vector having origin means 0 0 0 as initial and say ABC, a point P which has coordinates ABC as the terminal point, it is called the position vector of the point P with respect to origin, whose magnitude will be given by our above formula. So this formula gives the magnitude of a position vector. Now we will be discussing about direction angles, direction cosines and direction ratios, a somewhat important topic. So suppose if you consider the position vector of a point P which has coordinates x, y and z. Suppose it makes angles of alpha, beta and gamma with the positive directions of the x, y and z axis respectively. Then these alpha, beta, gamma, they are actually called the direction angles. The cosine values means when you take cos alpha, cos beta, cos gamma, they are called the direction cosines of the vector. And these direction cosines you generally denote by L, M, and N. That means you have cos alpha is L, cos beta is M, and cos gamma is N. Now if you see the direction, suppose if you want cos alpha, because see it makes basically if you consider and join the points, it will be making right angle triangles with the 3 axes. So cos, by the formula of cos, you will be having cos alpha as x upon the magnitude of the vector, cos beta is equal to y upon the magnitude of the vector, and cos gamma is equal to z upon magnitude of the vector. So now suppose if I make x as subject of formula, x is basically L into the magnitude or L into cos alpha. Similarly y and z. So now our P which had coordinates x, y and z can also be said to have coordinates L into R, M into R and N into R. Now these numbers LR, MR or NR, they are proportional to the direction cosines. So they are called the direction ratios of the vector. So basically the coordinates of P which are expressed as LR, MR and NR, these are called the direction ratios of the vector. Now, if you note over here, the sum of L square plus M square plus N square is equal to 1, because cos square alpha plus cos square beta plus cos square gamma will be equal to 1. But it is not always necessary that A square plus B square plus C square will be equal to 1. Correct? So this we will be seeing with the help of an example. Now there is often confusion between direction ratios and direction cosines. Let us understand that. The direction cosines of a line are the cosines or the cos values of the angles between the line and the positive x, y and z coordinate axis. Correct? We just now saw that cos alpha, cos beta, cos gamma, they are the direction cosines. Now this triplet L, M, N is called the set of the direction cosines for the given line. Now direction cosines are unit vectors in the direction of the line. Hence, the property that L square plus M square plus N square is equal to 1 holds. And we can see that the formula for L will be A upon root of A square plus B square plus C square. That means the magnitude. Same way cos beta and cos gamma. So you can see that L square plus M square plus N square will be equal to 1. So these are direction cosines. Now direction ratios are the three numbers A, B, C which we are having that are proportional to our direction cosines. So direction ratios, they need not be unique. Direction cosines are unique, but direction ratios need not be unique. If A, B and C are the direction ratios, then also Ka into Kb into Kc, they can also be direction ratios for any scalar. That means if you multiply any scalar by your A, B and C, then they will also be the direction ratio. So they are not necessarily unique. So main difference between them is direction ratios are not unique, while direction cosines will always be unique. So we have L square plus M square plus N square is equal to 1, but A square plus B square plus C square is not equal to 1 always. For example, suppose if you are having a line which has direction cosines 1 upon root 3, 1 upon root 3 and 1 upon root 3. Then you can say that 1, 1, 1. This can form a set of direction ratios. But also 2, 2, 2 can also form a set of direction ratios. So we can conclude that direction ratios are not unique, but direction cosines are unique. So let us take some examples to understand this. First simple example, find the direction cosines of a line joining the points A 2, 1, 2 and B 4, 2, 0. Now if you want the components for the vector A to B, remember B is your endpoint, A is your starting point. So what you have to do is, since A is with respect to origin, B is also with respect to origin. So now if I want AB, the components for the vector from A to B, then how will I get them? The x coordinate will be B minus A 4 minus 2. Same way for Y 2 minus 1 which is 1, and Z it is 0 minus 2 which is minus 2. So now basically first of all, these are the coordinates of your vector. So these are the direction ratios. Now to find direction cosines, first find the magnitude of your vector. It is root of 2 square plus 1 square plus minus 2 square which is 3. So your direction cosines are x upon magnitude, y upon magnitude and z upon magnitude. Means direction cosines are 2 upon 3, 1 upon 3 and minus 2 upon 3. So this gives a clear-cut explanation of direction cosines and direction ratios. Second example, find the direction angles of a vector with direction cosines given as 1 by 3, 2 by 3 and 2 by 3. So now we have the formula, you already know the formula, cos alpha is equal to L. So what is alpha? Cos inverse of L, which is cos inverse of 1 by 3. Same way beta is cos inverse of 2 by 3 and gamma is cos inverse of 2 by 3. And you can also verify over here from the example which is given, always you will have L square plus M square plus N square is equal to 1. Now some types of vectors. Zero vector, a vector whose initial and terminal points coincide, means they are the same points, is called a zero vector. Obviously it will have zero magnitude. Unit vector, a vector whose magnitude is 1 unit, is called a unit vector. The unit vector in the direction of a given vector A is denoted by A cap. Co-initial vectors, two or more vectors having same initial points. Collinear vectors, two or more vectors are said to be collinear if they are parallel to the same line, irrespective of their magnitudes and directions. Remember this, irrespective of their magnitude and directions. Equal vectors, two vectors are said to be equal if they have the same magnitude and direction regardless of the position of their initial points. That means if the components are different but the magnitude is same, then they will not be equal. Why? Because you need the direction also to be same. Negative of a vector whose magnitude is the same as that of the given vector but the direction is opposite. For example, vector from B to A is negative of vector from A to. Before solving the example, some points to remember. Just now, as I said, if components of two vectors are different but the magnitude is same, then they will not be equal. The vector sum of three sides of a triangle taken in order is zero vector, because you start from the same point and end at the same point, A to B, B to A, A to B, B to C, and again C to A. Third point, the vector sum of two co-initial vectors is given by the diagonal of the parallelogram whose adjacent sides are the given vectors. Now, for a given vector A, just now I said the unit vector is denoted by A cap. So the unit vector A cap is given by vector A upon its magnitude. Remember this. A very important formula, which is a section formula. You already have studied the section formulas for, say, line segments. Here we are going to see the section formula for vectors. We divide it into two parts. Either you have the internal division or you have the external division. Now, the first case, suppose internal division. That means if A and B are 2 points with position vector small a small b, and C is a point dividing AB internally. You can see C is a point which is between A and B. It divides AB internally in the ratio M is to N. Then the position vector of your point C is equal to OC. O is origin, O to C. So OC is equal to M into vector B plus N into vector A upon M plus N. Similarly, if you have external division, that means it divides externally. You can see in the diagram that you have OQ and OP and the point R. It divides PQ externally. Then in this case, OR, the vector OR is equal to M into vector B minus N into vector A upon M minus N. You can see from the diagram these two results, they are important results, internal division and the external division using the section formula for vectors. Now some examples to understand the basics of vector algebra. Two vectors which are having same magnitude but they are not equal. You have to give example of two vectors that have same magnitude but they are not equal. Just now as I said, even if the magnitude is same, if they have different components, then they are not equal vectors. So suppose if I take vector A, which is I plus 2j plus 3k, and B is 2i plus j plus 3k. You can verify over here that the magnitude of both the vectors is same, but their components are different, so they are not equal vectors. Give example of two different vectors having same direction. This also we have seen. Remember, when they are having same direction, one vector will be the scalar multiple of other. Then only they will be having the same direction. So suppose vector V is I plus 2j plus 3k, and if suppose vector W is 2i plus 4j plus 6k, you know that you can see that W vector is equal to 2 times the vector V. So in this case, they are two different vectors, but they have the same direction. Find the unit vector in the direction of the given vector I plus j plus 2k. Unit, just now we have seen the formula. Unit vector is given. How do you get the unit vector? Unit vector is given by the vector divided by its magnitude. So first of all, our given vector is I plus j plus 2k. Its magnitude will be root of 1 plus, means root of 1 square plus 1 square plus 2 square, that is root 6. So our unit vector denoted by a cap is equal to vector upon its magnitude. So it is equal to 1 upon root 6I plus 1 upon root 6j plus 2 upon root 6k. Next example. Find a vector in direction of the vector phi I cap minus j cap plus 2k cap which has a magnitude of 8 units. Now if you want to find a vector which is in the direction of the given vector and having magnitude of say 8 units, to first find the unit vector which is in the direction of the given vector. Multiply that unit vector by 8. So you will be getting a vector which has magnitude of 8 units. So now first thing is, just now we have seen the formula to find the unit vector in the direction of the given vector is equal to the vector upon its magnitude. So the unit vector a cap which is in the direction of the given vector a is equal to 5 upon root 30I minus 1 upon root 30j plus 2 upon root 30k. Magnitude of 8 units means when you multiply 8 by the unit vector, you will be getting the vector which has magnitude of 8 units. So the required vector is 40 upon root 30I minus 8 upon root 30j plus 16 upon root 30k. Next example, show that the given vectors are collinear. Now collinear vectors by definition means they are on the same line or maybe parallel lines in the same or opposite direction. So basically if two vectors are collinear, then one of the vector will be a scalar multiple of the other vector. So from the given vectors, it can be seen that the vector v is minus 2 into the vector u. So over here that scalar factor is minus 2. So we can say that the given vectors are collinear. Next example, find position vector of a point R which divides the line segment joining the points P and Q, whose position vectors are I plus 2j minus k and minus I plus j plus k respectively in the ratio 2:1. Now this question, since it is not given whether the position vector R, it divides the line segment joining points P and Q internally or externally, we will find in both the cases. Suppose it divides internally, then what is the formula? M into vector b plus n into vector a upon m plus n. So your m is 2, n is 1 over here. Just use the formula. You will be getting your required vector OR as minus 1 upon 3 I cap plus 4 upon 3 j cap plus 1 upon 3 k cap. Similarly, if suppose it divides externally, then the formula is m into vector b minus n into vector a upon m minus n. So in this case, your vector OR will be minus 3i plus 3k. Students, in the next part of vector algebra, we are going to see a very important topic which is used almost everywhere, which is the dot product and cross product of two vectors. So do subscribe to the channel. Like and share the video and subscribe to the channel.